Welcome to today's session. Today we're talking about performing transformations on your raw change data feed with Databricks. And we are here with our experts from Databricks, Nikhil and Guy. And with that, I'll just go ahead and turn it on over to you, Nikhil.
Hey, good afternoon, everyone. This is Nikhil Gupta. I work as a solutions architect at Databricks, and alongside with me, I have Guy. So, Guy, please go ahead.
Hello, nice to meet everyone. My name is Guy Brachiali, and I'm part of Databricks Solutions Architect team dedicated to Azure Databricks. So nice to meet everyone.
Perfect. So the topic for today is just going quickly to share the screen. So the topic for today is enhancing incremental ETL, and primarily we will be using the Delta Lake's CDF feature. And today we'll go in and deep dive into what the CDF basically stands for and what's the functionality all about. So before starting, let's look at the problem statement, right? So what is incremental ETL? So incremental ETL basically takes the raw data, which comes from various raw systems, and then refines it through a Delta Lake medallion architecture. So Delta Lake medallion architecture is bronze, silver, and gold layer. So the data moves incrementally processed through these layers. This architecture is enabled because of the merge operation capabilities and the log versioning capabilities in Delta Lake. So recently we came out with a new feature called the change data capture. So change data capture basically, along with the medallion architecture, provides multiple benefits to the users because only now the changed data will move through the architecture. And we will look into what the CDF means and some use cases around that as well. So change data capture is one feature that many customers of Databricks have implemented, and let's quickly go in and have a look at it. So why did we come up with this feature, which is basically the change data feed, right? So the challenge is right now, if you look at it from the ETL side, the earlier challenges we saw in multiple number of customers was it was really hard to find the changes from version to version in large tables. So suppose you are moving your data through various stages, it was really difficult to record what changed where and when. Now, the problem here was we had to basically go in and even rewrite tables, which was a big drain of resources. The second one was doing real-time analytics. If you are doing real-time BI or use cases, recalculating the full data sets because of a small change in the source system was not functioning. Recalculating the big tables caused downtime and was incompatible with real-time needs. And the third challenge that we saw amongst various customers was producing an audit trail. So there are use cases where customer needs to understand what changed where, and they need for the audit purposes. And digging through all versions of the previous data sets was impractical and did not meet the requirements. So looking at these challenges, we came up with something called change data feed. So what is change data feed? This change data feed basically represents capturing of lower level changes between different versions of Delta table. So if you look at it here, we have a medallion architecture or a multi-hop architecture from bronze to silver to gold, right? So if we enable CDF on this architecture, we could capture what changed and where it changed. So when we enable the change delta feed on the Delta table, the runtime records of the change events are logged. And this include not only the data, but also some metadata indicating which specific row changed and what values changed. So let us take an example and look at it, how it works. So I have a table over here. This is my original table. It has some values A1, the primary key is A1, A2, and A3, and it has some values of B1, B2, and B3. Now, due to some changes, we merged it with another table, things changed. So the value of A2 changed from B2 to Z2, A3 row was completely deleted, and we added a B4 row. Now, if the table had change data feed enabled on it, and we looked at the change data feed, we would get a pretty good information. The first thing is I'm able to see that before the row changed, the value of A2 was B2, which was pre-image, and it changed to post-image, which was Z2. So now I know the value of my primary key changed from B2 to Z2. I can also see that A3 row was completely eliminated from my original data set, and we added a new B4 row to it. Now, this is a small data set. Imagine millions of rows and a few changing happening on your data set, and you get exactly what you need, what changed, and how it changed. So this is what the functionality of CDF brings into. And now I can take this only the change data feed output set, and I can go in and use this to merge it to my downstream data sets, a goal table, and I don't need to my entire tables to be rewritten or recomputed. So what are the typical use cases? What are the typical use cases of my change data feed? The first is, improved delta performance for my silver and gold tables. So now I don't have to go in and merge the entire big tables. I can take only my change data feeds log tables and merge it to my silver and the gold tables. I can create up-to-date aggregated views and then without having to reprocess the whole tables, and just propagate the changes as they come through. And finally, the audit trail. With my change data feed outputs, I exactly know what changed and which rows changed and what are the values that changed. So whenever things occur, I am able to give it to my audit team, and they can do the full audit on that. So let's go back to our example. So the example for today, we would be concentrating on looking at this is a small data set which we create. So the data set is basically of earning per share or EPS, which various analysts are predicting for different companies. So the raw data can come from variety of different sources and from multiple analysts and multiple stocks. So we can capture data from a variety of sources, which would be a raw data. And then we go in and put it into the bronze layer or the ingestion layer. And then finally, what we will do is we'll move that data, filter it, little bit cleaning, and then move it to the gold layer where we would move it to the other BI tools can go and process that data. So the idea for today is we would concentrate on incremental ETL within our medallion architecture. We would look at features such as Autoloader and structured streaming and see how we can do incremental ETL in real-time fashion. So before going onto the notebook, I just quickly want to showcase one or two features of the Databricks platform, and particularly the compute and the notebook. So if you look at it here, I have attached my notebook to a clusters, and I have various numbers of clusters over here. So I have added, I have chose one of the clusters, and I'm running my notebook on it. So compute in Databricks is called clusters. So what clusters do is they are a bunch of VMs on which Databricks install its runtime, and they can go in and do distributed processing of your data. So I have a cluster over here. I can choose any number of clusters, and I choose one of the clusters and do it. The second thing is I'm writing all my code, my markdowns inside a notebook. So this is what is Databricks notebook. So although this is the beauty of this thing is I can write multiple languages within a single notebook. So although the notebook is a Python notebook, I have some markdown commands on it. I'm probably writing some SQL commands on it. And using some magic commands, I am able to write multiple languages within a single notebook. So that was a very brief overview of the Databricks, right? The two things which I'm using, the clusters and the notebooks. So let's move down. Let's start looking at it. So for today's demo, what we would do is we would be enabling the change data feed onto the Silver, only on the Silver table. So I would have some raw data coming, which I would be moving into the bronze layer, and then in the Silver layer, I would have my change data feed enabled, and then we would real time use the output of the change data feed to populate the gold tables, which could be used by the downstream applications, maybe your BI tools, or if you want to go and create some machine learning models on top of them, you can use your gold tables to do that. So how do I get CDF enabled? So in order to enable CDF, we have to explicitly mention inside the table properties whether we want to enable the change data feed. So if I mention delta.enable change data feed is equal to true, it would be enabled. So the change data feed does not come by default. You have to explicitly mention on top of your table that you want to enable it. And there is a couple of reasons from that, right? So once you enable the change data feed, only a specific runtime cluster that is 8.1 and above can read and write that table. If you have a cluster below that runtime, you probably won't be able to write anything onto that folder. So yeah, so you have to go in and explicitly mention that change data feed is equal to true. So as a next step, what we do is we create some tables. So if you look at it, I'm creating 3 tables over here, the bronze, silver, and the gold. So I very simplistically, I just create a bronze table. I have a few columns which I want to create on it. And then the silver table, I want it to be enabled with CDF. So I do delta.change data feed enable is equal to true on my silver table. So I've explicitly mentioned that for this table, I want the change data feed is equal to true. And then I go in and create a gold table, which would be an aggregation of the silver table. So now if we go in and have a look at it, the first thing I do is I'm just creating a dummy data set, which has some dates. It shows some the A is the stock which I'm covering. 1 is the analyst and 2.2 is the rating which the analyst has given. So very simplistically, I just create a very small data set and I store it as a CSV file in my landing location. So if I go in there and I have a look at it, I can see that I have my CSV file which has been created inside my landing location. Now there are a couple of ways to ingest that CSV file. If you look at documentation, you can do it by something called Autoloader. You can use a copy into command, different ways to ingest this CSV file incrementally. So we'll look into, all those things in a bit. So now my CSV file is all ready. I would go in and I would use an autoloader to ingest the file. So just a brief about autoloader. So what does autoloader do? So think of autoloader as a person who is listening to your raw folder. And as soon as the file comes in, it will incrementally pick that file, new file, process it, and move it into a Delta Browns table. Now this can be on 24/7. You can have your autoloader running 24/7, or you can do a trigger once option in which you can say, if you run this job, say by daily or nightly jobs, or say even weekly jobs, you use a trigger once options. So once the autoloader is running, it will go to the bucket it's listening to. It will pick up the new files, process them, and then move it to your Browns layer, right? That is what Autoloader does. Very easy to ingest files, to move raw layer to the Browns layer. It's a really great tool. So how does it do that? So basically Autoloader works on the format for cloud files. So I say this is I want to read my files. The schema is the Browns schema where I want to store it. And then, I want to say, okay, read the files from the landing zone, which are CSV files which are saved, and then write it back as Delta format and into the Browns EPS table, right? So this is my table, the Browns table, which we created. And as the streaming process kicks in, the data is moved, is copied from the CSV files into the Delta folder, into the Browns folder. So if I go in and I go in and I do a select star, I can do a select star from Browns EPS, and then I'm able to see the data set which we just moved inside. So if you see date, stock symbol, unlist, and estimated. So pretty easy to do that. We just quickly moved my raw table to my Browns table, right? So we did step one over here. The second step, what we will do is we'll move from bronze to silver. And we can do an autoloader as well. But the idea here is we will just quickly do a quick stream processing to move the data real time. So I just do DF silver write stream, format delta, and then move the data from my EPS. So this is my silver EPS. I would go in and move my data, which is stored in DF silver, right? And then move it to my silver EPS table. Now remember, this table has changed delta feed enabled on it, and we will see how does it really help us, right? So we did step 2 now. We move table 1 from say bronze to the silver layer, right? Very easy to do that. So now if I go and I go in and I look at my silver table, I can see that the data has been populated into my silver earning per share table. Now let's do the second. Now let's assume we have new data coming in. So it's day 2 and the new data comes in. And for the demo purposes, let us concentrate on this row, the 31st, third of, let's concentrate on this row, right? It's 3/1/2021, analyst A, stock A, analyst 2, and 2.5. So now what happens is a new data comes in the landing zone as a CSV file. And I use Autoloader. And now I use Autoloader to append this new data onto my bronze layer. Now, advantage here is Autoloader will go in and only process the new files incrementally. It's not going and processing the older file as well, right? So that's the real advantage over here. It's incrementally processing the data. So I do this here and I am able to see my bronze layer, bronze table, which has which has the data appended. Now just concentrate on this 3/1/2021. And if I look at it here, I have two rows for analysts. This was the older row, which is also present in my silver table. And this is the new row, which is the updated EPS, estimated EPS from the same analyst, from the same stock on the same day, right? So I can see two rows for the same analyst, stock and date, right? And two values for it. So this is the old value and this is the updated value. So if we look at it here, we have the updated value on this end, and then we have to do updated value here. Now comes the fun part, right? Now what we do is I go in and merge my we do a merge from bronze to silver, right? We do a quick merge from bronze to silver, and we see and I do a merge on both date, stock symbol, analyst, right? And when everything is matched, then update it, or if not is matched, insert all, right? So there are a bunch of rows which will be updated. There would be a bunch of rows which will be inserted inside my silver table, right? And then I just quickly stream it. So the entire demo is based on structured streaming and Autoloader to show like how easy it is to do real-time analytics onto the Databricks platform, right? So I do a write stream, format delta, and then I upload the data onto my bronze layer, right? A silver layer. And once I do that, I see that my silver table has changed from 3/1/21. The estimated has been updated from 2 to 2.5. So we had the first original silver table here, right? The original silver table was here. The same EPS was 2, and now it became 2.5. So now you see, right, the table has been updated. The silver table has been updated, right? And now I want to go into my change delta feed and I want to see the change delta feed log and see what happened over here. So if I go in here, I read my change delta feed, and I start looking at it, and I can see. Let's go to this one, right? So if you see over here, right? So I can see over here that pre-image, my estimated EPS was 2, which got changed post update, it got changed to 2.5. Now I exactly know my row the date 3/1/2021, stock symbol A, analyst 2, and the estimated value for this row basically went in and changed from 2 to 2.5. So I have now I have full visibility of which row changed, right? And there were a bunch of inserts. We are not like looking into it as much. We'll focus most of our attention on this this guy today, right? So we'll focus over here, and we can see that what changed and when, right? So we have an idea of we have the log of the change that happened. Now, the third part is I have my goal table. My goal table is basically what is, we'll go and create a goal table right now, which basically goes in and aggregates this. So for stock A, I will aggregate both analyst 1 and analyst 2 predictions and come up with an average of estimate EPS, right? So we had a goal table which had that, and then we want to repopulate our goal table, but just only do the change over here. We don't want to do the entire calculation once again. We just want to use the changed value and do the change calculations. So the real-time analyst was sitting on Power BI or other BI tools can quickly go and see real-time changes. So how do I go do this? So streaming aggregation can be a little bit of complex. And the idea here is, the code is available on the GitHub. The idea here is just to get an understanding of how, we'll go in and aggregate things over here. So what we do is we just go in, I create a function called silver CDF1, right? And then what we go is I just go and aggregate my function, group by date, and then and stock symbol, and then average of the estimated EPS, and then we just give it a name of consensus EPS, right? So I look in it here from my table. I can see that this is my goal table. Only for a single date, I'm able to get what my estimated EPS was, right? And then the next portion is aggregating, sending those aggregations, sending the change aggregations into the goal table. And that's also pretty easy to do that. So what we do is we use something of a macro batch output data frame. In which we take the CDF distinct CDF ranges from silver table, do some aggregation on top of that, and then go in and join it to our gold tables. So that's easy to do. So I go in, I take my two tables, which is my the silver table, the CDF table, merge it into the gold table. And once I have that, I stream it to the original version of the gold table. And once I do that, I have my entire gold table, which was updated using my using the CDF over here. So now I can see my gold table, which has been updated in a very incremental fashion. So yeah, once again, the purpose of today's demo was to understand how to easily do incremental ETL, which is really essential for your real-time processing use cases, for real-time analytics use cases using the Delta Lakes CDF function. Okay, yeah, Guy, I think.
Thanks, Nikhil. There are some questions on the Q&A session, Nikhil. You answered some of them, but if you could, while I present the next part, if you can take a look at the questions.
Sure, I'll be answering them.
Okay. Let me share my screen. Can you guys see my screen?
Yep, there it is. Okay,
perfect. Okay, so what Nikhil presented today was the change data feed between Delta tables. What I'm going to present next, it's a similar concept, but I will show how to capture the change from Cosmos DB that is typically used for application transactional data, and how to ingest these into your lakehouse. Okay, so all the details of the demo is available on this blog post that we published back in November last year, and this is on a Microsoft Tech Community space. Okay. Moving to the notebook, that is exactly what we covered into the blog post. I share here a reference architecture for the lakehouse running on Azure Databricks. So on the lakehouse architecture, typically the source data comes from transactional systems such as the Cosmos DB, event hubs, or from a variety of sources that is captured by Azure Data Factory here. We are just representing a single icon here, but Azure Data Factory can connect with text files, database, and other sources. So on the lakehouse architecture, we use Databricks to do all the ingestion and transformation. And as Nikhil mentioned, we follow the medallion architecture, where we have the bronze, silver, and gold layers. In this architecture, all the data is stored on the Azure Data Lake generation tool, which we call ADLS, using a Delta Lake format. Once the data is transformed and processed and cleaned for business, we can connect to tools such as Power BI for business users to connect the data. We can have data science running machine learning experiments and creating models. And we can also send this data back to applications. So what I'm going to cover today on the demo, I will focus a lot on how to use a very efficient way to read the data from the Cosmos DB and load this data into the Lakehouse. So the main idea to optimize this process is, instead of reading the Cosmos DB full data set all the time, we are only going to read the change from the Cosmos DB. So by doing this, it helps in two pieces. The first one is we are not going to overload Cosmos DB with a bunch of transactions or a bunch of workload to read the data. As we are only going to read the new records or the change, that's going to be very, very lightweight for Cosmos DB. So that will definitely reduce the size and the cost of Cosmos DB, and it will make it more performant as well. The second benefit is we can capture those changes in near real time. So I'm going to show that we can create a streaming process to get all those changes and store that on the Lakehouse and make it available for models or even for business analysts. So just to get started, I created a Cosmos DB here, and I used one of the sample Cosmos DB dataset that's provided by Microsoft. That's called the family dataset. So if I go to my Cosmos DB here, I have my family container, and here we have some examples of the data that is stored on Cosmos DB. It's a very tiny, simple dataset, but that's what we are going to use for our demo. And it's very simple for everyone to reproduce those notebooks by following those Microsoft tutorial on how to get started with Cosmos DB container and data. So once we have the Cosmos DB configured and with the sample data, all we need to do is to install the Cosmos DB connector. This is an open source connector provided by Microsoft, and we need to attach this to our cluster. As Nikhil showed, we can have different clusters configuration on your Databricks environment. I'm using here a sample Cosmos cluster with this library installed. Okay. So with the Cosmos DB available and with the connector installed in the cluster, all we need to do is to provide the directions and the secrets for this Cosmos DB to make this connection. Okay. So the first step I'm going to do here in terms of getting started with my historical data on my Lakehouse, I'm going to do one full extraction from Cosmos DB. It's very important to mention that this full extraction we just need to do once, because we are going to build the initial historical data inside our Lakehouse. Once this process is done, all the next ingestion are going to be on incremental ingestions. Okay, so just the first time we do this, we are going to do this full extraction from Cosmos DB. And here I can run a select. So what I did here was providing the connection with Cosmos DB, and I'm storing this data, this full data set from Cosmos DB into a table using Delta format. Okay, so if I do a select on my Delta table, this is already my Lakehouse. We will see that we have the exactly same data that is in Cosmos DB. The only difference is here in Cosmos DB, this is a full JSON format, and here in our Lakehouse, this is already in a table format. Although we have this kind of complex data types, so for example, the children attribute is an array with multiple records. So this was automatically parsed and translated from Cosmos DB into a Delta Lake table with all the details and all the nuances of the schema for this table. So all the attributes and all the columns that we have on Cosmos DB are immediately available here on the Lakehouse. Okay, so In order to simulate this change data feed, what I'm going to do is I'm going to simulate I am in a web application or a mobile applications writing data to Cosmos DB. So this process here is not part of the ingestion, just to simulate that we are writing some of the records in our transaction or in our application data. Okay. So when I run this command, in this case, I'm just going to add like 5 new records into my Cosmos DB table. So if I come back to Cosmos, just to show what we had here, I'm going to do a refresh. So we had initially only 2 families in our data set, and now I added the families leaf 5 times. So we have 5 new records in our Cosmos DB data set. Okay. So this is pretty much what this process did. And now we are going to show like the real change data feed ingestion that is part of this demo. And this is, in my opinion, the most exciting part. So again, we are just providing the connection details with Cosmos DB, such as the URL and the secret. And this time, instead of doing a full read from Cosmos, what we're going to do is to use this option that's called change feed. This is part of the Cosmos DB connector provided by Microsoft. So by doing this, I will get a data frame here into my code that will have only the change that happened. So imagine that we have a historical table from Cosmos DB with multiple billion of records. When I do this, I'm not going to reload or re-extract all those historical data. I'm just going to get the change. So in this specific example, I'm just going to get those 5 records that were changed. All the historical data will not be extracted again. Okay. So once I have this data set that I'm calling change feed data set, what I'm going to do is I'm going to merge these chains back into our Lakehouse Delta table. Okay, this is what this code is doing here. And like I said, we can run this process in a streaming way, or we can do this in batch. So if we decide to run this every hour, it will just get the change since the last execution. And Databricks streaming automatically manages the checkpoint, and Databricks will know exactly when was the last checkpoint and what records need to be extracted. Again, by doing this option here, trigger once equals true, we are going just to use this to run in batch mode if we want to run every 10 minutes or every hour. But if we change this trigger once to false, this process will run in a streaming way. So it means that the second the record arrives in Cosmos DB by the transaction application, it will immediately be available on the Lakehouse for business users or for data science or for the bundles to use this data on the Lakehouse. So I'll execute this code now, and we will see that all the changes that we made there will be available on the Lakehouse. Okay. This will take only a few seconds. And like I said, the families data set is a Delta table. And as part of the Delta table format, we have this idea of ACID transactions. And we have every single operation, or every single transaction that happened in this table, it's registered here. So we can see that a few minutes ago, we did the initial extraction, then we recreated and replaced the table. And now a few seconds ago, we did this merge where we executed those changes that existed in the Cosmos DB. And again, if we run the same query again that we executed above, where we had only 2 families when we started this demo here. So initially we have only those 2 families. If we execute it again, we will see all the 5 new records that we created. So by executing these, we have the 2 initial families that we didn't touch, and we have 5 new records, which is the 5 versions of the family Smith. And I put a timestamp here on the last name just for us to be easy to recognize that. And again, we can easily change this process to run in a streaming mode and get those changes immediately available. Now, this table here, it's a Delta table, and it's available for Power BI to connect and for the business users to run reports on the data that is updated in near real time or it's available for you to run a data science model or any other type of analysis that you can do using Databricks. So this is what I wanted to cover for today. Again, all the details are provided here on this blog post, and we are also going to provide this notebook as part of the Dev Radio page that we have on the GitHub, along with the other demo that Nikhil made. So I would like to thank everyone, and Nikhil, I'll get back to you guys.
Thanks so much. That's some pretty sophisticated stuff today. Nikhil, I'll go ahead and push you back on live.
We had a good.
Okay, I think we're good. Are we gonna any more questions or anything from the audience that we want to take, or are we all good for today? If anyone does have any questions we weren't able to get to today, please go ahead and send mail to msusdev@microsoft.com. And we look forward to seeing you in the third part of this. And I'll go ahead and quickly put the link into chat right after we end. And thank you so much.